After data are collected, researchers test hypotheses related to their research questions in order to make a decision about whether there are any real differences. The goal is to try to understand something about a larger population based on samples drawn from that population. We can never be certain about research results because sample information is necessarily limited and variable, and therefore doesn't always provide an accurate representation of the population. This is where statistics come in. Using statistical methods allows researchers to make decisions based on probability. Hypotheses are developed from research questions. Researchers in the Henniken-Henderdos et al. Study weren't expecting one device to perform better than the other, so the research questions asked whether there was a difference. A hypothesis is a precise testable statement related to study results. There are two types, null and research, and they refer to the populations to which results will be generalized. The two statements account for all possible study outcomes. The null hypothesis states that there is no difference, and the research hypothesis states that there is a difference. The way hypothesis testing works is that researchers create a theoretical model of all possible results that can occur when the null hypothesis is true, and then compare their results to that model. If the model is not a good fit to the data, the researchers reject the null hypothesis and conclude that the research hypothesis is a better fit. Here are the research hypotheses. Hypotheses are precise statements, so they include the parameter being tested, a difference in means. Each research hypothesis has a corresponding null hypothesis of no difference. The researchers used paired t-tests because each subject had scores under both treatment conditions for each outcome. The researchers state that p less than 0.05 was considered to be significant. This is their threshold for rejecting the null hypothesis. Any result that happens by chance less than 5% of the time will be taken as evidence against the null hypothesis. The researchers could also have written this in more standard form by saying that the significance level used was 0.05. The analysis followed an intention to treat protocol, which is the current standard for clinical trials. In this protocol, all subjects are included in the analysis, whether or not they were compliant with instructions or even completed the study. The other analytic approach is called per protocol, which includes only those subjects who followed the proper protocol and completed the study. The intention to treat protocol keeps the balance of randomization because no one is excluded. It also gives a better idea of true treatment effectiveness because it better reflects real-world adherence. Per protocol analyses may overestimate the size of an effect because it excludes those who did not follow protocol exactly. However, it provides a good estimate of treatment efficacy, that is, how well the treatment works under ideal conditions. Here are the study results for bleeding on probing. 42 of 44 subjects completed the study. The left side of the table shows experimental phase results when subjects did not brush. The proportion of sites with bleeding increased from day 0 to day 21 as expected. This must be an artifact, as a proportion over 1 would not be possible. During the treatment phase, differences were analyzed at each week. This last row shows p-values, expressed as a proportion or probability. The p-value indicates how likely it would be to see a sample difference of this magnitude when there is no true difference between treatments. They are interpreted relative to the significance level. Any p-value less than 0.05 will lead to rejection of the null hypothesis, or a statistically significant result. Here's a good way to remember when to reject a null hypothesis. If the p is low, the null must go. If we look across the row for p-values, we see that the only statistically significant difference between treatments occurred at week 4. The second half of Table 1 reports plaque index results. Again, there was an increase from day 0 to day 21, but there was no statistically significant difference between devices at any time point. The mean number of sites with gingival abrasion decreased between day 0 and day 21, which is not surprising because subjects did not brush their teeth during this period. There was a significant difference in gingival abrasion between the two devices at all 3 treatment phase visits. In every case, mean abrasion was higher for the nylon bristled brush. There was a statistically significant difference in subjects' mean perception of the devices for 5 of the 7 items. These data appear in a supplement and not in the main article. Comparison of means indicates more favorable perception of the rubber bristled device. There was no significant difference in perception of either cleaning effectiveness or quality between the 2 devices. To summarize, they found a significant difference in bleeding on probing, but only at week 4, providing partial support of this research hypothesis. There were no significant differences in mean plaque index, but significant differences at all treatment phase time points for gingival abrasion. Finally, there was a significant difference between devices for 5 of the 7 patient perception items, providing support for most of these research hypotheses. Statistical significance indicates that results are more likely under one scenario, a true research hypothesis, than another, a true null hypothesis. Significance in this sense does not mean important or meaningful. The researchers touch on this by referring to theoretical versus practical efficacy. If a patient is not motivated to use a particular interdental cleaning device, it does not matter that it is shown to be statistically better than another device. They suggest that the results are clinically important because subjects preferred the rubber bristled device. Every study has limitations, which should be acknowledged and addressed by the researchers. This study noted that only one version of each device was examined. It also mentions limited areas used to measure bleeding, the inability to blind subjects to devices, and the short study duration as potential shortcomings. One aspect of the study that I wondered about, but that was not addressed in the article, is the difference in shape between the 2 devices. The curved handle of the rubber bristle brush may have made it easier to use, thus potentially confounding the effect of the material, rubber versus nylon, with shape, curved versus straight. Everything begins and ends with your patient, so let's return to the original scenario. Your patient asked about interdental cleaning devices. Can you recommend one? Would you recommend one? Here are the study results, but these are only one consideration in making treatment decisions. The scientific evidence in favor of rubber bristles appears to be sound, and the study also suggests that patients might find it easier to use and more pleasant, with less perceived gum irritation. Cost might be another patient factor to consider. Finally, what is your professional opinion, based on the research and your patient's needs, as well as your own experiences? When discussing this with your patient, you need to consider the strength of the evidence, as well as your patient's wants and needs, and your own professional opinion and experience, to determine together with the patient whether this is something that is in her best interest. I have skimmed over many concepts very quickly, so if you would like to know more about this study, or if you have any questions about it, or about research design or statistics in general, please feel free to contact me.